Hi everybody, so this is the video to go with the chapter 3 notes. I also want to mention that if you hear soft snoring sounds, it's because my cat is sitting right behind the computer and snoring. So it's not me. I don't know if you'll be able to hear it, but it's pretty loud. Okay, so in chapter 3 here, we are moving on. We're using a lot of what we used in chapter 2 about distributive property and combining like terms. And we're going to put those together to talk about solving equations. Okay, so we'll be solving linear equations, we'll be solving linear inequalities. So there aren't as many, different topics as there were, let's say, in chapter 1, but we're going to be putting a lot of things together in these topics. So let's just for a second talk about equations and what we're thinking about when we have equations. So when we have an equation, we know that we have an equal sign, okay? And we know that the two sides of that equation are equal, right? So for example, I might have something, if I had an equation, oops, it's E, and it said 5 equals 2 plus 3. That would be an equation because the left side is equal to the right side, right? The left side has a value of 5. The right side also has a value of 5. If I have something like 5 equals x plus 3, then what I'm trying to do is figure out what value of x, what could I substitute in there that would make that right-hand side true, right? If I had 1, does 1 plus 3 equal the same as 5? Or if I have 2, does 2 plus 3 equal the same as 5? Or if I had 12, does 12 plus 3 equal the same as 5? So when I solve an equation, I'm trying to figure out what value of x makes that true. And we call these linear equations, what we're going to work with today, because I have x to the first power. Now I don't usually write the 1 in there, right? But it's just x to the first power. It's not x to the second power or x to the third power. We'll get into some of those at the very end of the semester. But for right now, linear equations. So basically, in general, we're going to have equations that only have one valid answer, okay? One solution. So let's look over here for a minute where we say a number is a solution of an equation if it makes the equation true. Or in other words, if it makes the left side of the equation equal to the right side of the equation. So in my example over here with 5 equals x plus 3, the value of this, the solution of this would be 2, because if I plug in 2 for x, it makes the two sides equal. So for this first couple examples, we're trying to figure out if the given answer satisfies the following equation. In other words, does it make that equation true? So we can, one way we can do this is we can substitute in, I'm just going to write it in a different color, the value, oops, it's not supposed to be 2, is it? Let's try that again. So my x is going to be 5, so I'm going to substitute in 5 where x is, and then rewrite everything else. Okay, now we know from order of operations that we're going to do what's in parentheses first. Before we do that, let's think about what we're trying to find here. We're trying to find if when x equals 5, does that left side actually equal that right side? If it does, then 5 is the solution to the equation. It satisfies it. If it does not, then 5 is not the solution. So I can use order of operations here. 2 times 2 is 4. So right now, all I'm doing is combining things using order of operations over here on the left side to simplify it. 4 plus 4 is 8. So all along this left side, I didn't really pay attention to what was over here. I just brought it down. Well, left side is 8. The right side is also 8. Okay, so my answer here is yes, x equals 5 does satisfy the equation. Okay, it is the value that makes that equation true. Now let me just point out one thing here. When we here have 2 times 5 minus 3, you might be confused, or maybe not confused, but you might be thinking, okay, well, last week we talked about distributive property. Why aren't we distributing? So in this case, we don't have to distribute because what's in the parentheses is like terms, so it can just be simplified. But if you can always distribute. So we always distribute if it were like 2 times x minus 3, where I can't combine those, but you can distribute in this case too. 2 times 5 would be 10, 2 times 3 would be 6, 10 minus 6 is 4. I get that same thing here. So you can do either one if it's an opportunity where they can be combined or can do distribution. Okay, so let's do the next one. Decide whether x equals negative 15 satisfies the equation. So again, we're going to substitute negative 15 for x. And technically at this point now, I'm trying to find out if those two are equal. So on the left side, I multiply these two because multiplication comes before addition. And then 45 plus 20 is 65. So now I have a single number on the left, a single number on the right. I look at them, they're not the same, right? So no, x equals negative 15 does not satisfy the equation. Or in other words, another way to say that is that x equals negative 15 is not a solution. Okay. So now, in this case, we were given a possible answer, and we had to decide whether or not it was the solution to the equation. Now we're trying to solve these equations, okay? We want to find the value of the variable that makes that equation true. We want it to solve the equation. We want to get that variable all by itself by moving everything else away from it, okay? So when we need to move an entire term, we can add or subtract. If we want to just get rid of a coefficient, we want to multiply or divide. A coefficient is the number in front of the variable. And this is really, and we'll talk about that in a second. So this is really important though, right? Whatever operation we do to one side of the equation must also be done to the other side of the equation. So if I have you separated into two halves of a room, and I give the left-hand side of the room a plate of cookies, and I give the right-hand side of the room a plate of cookies, and they're the same amount of cookies, okay? Then I come in and I give the left side of the room 10 more cookies. Well, to keep it even, I also have to do that to the right side of the room. Or if I take away half the cookies from the left side of the room, then to keep it even, I have to do the same thing on the right. So whatever I do to one side, I have to do to the other. Okay, so we need to solve these equations. So coming into Math 95, you should have a little bit of, what do I want to say, experience with solving equations. Okay, so let's just over to the side do a simple one, a one-step equation. So let's say we have 5x equals 20, okay? What's happening here is that x, some number, is being multiplied by 5 to get 20. So I want to kind of undo this, right? I want to find out what x is all by itself before it's been multiplied by 5. Because 5 times x is 20, but I want to know what x is by itself. So I want to do the opposite operation. If right here x has been multiplied by 5, I want to do the opposite and I want to divide by 5. And I'm going to do the same thing on both sides. Now another reason we would do this, anytime there's a number, we call this number in front of the variable a coefficient. Anytime there's a coefficient in front of x, or whatever the variable is, I want to divide by that because anything divided by itself always equals 1. So I don't want 5x, I want 1x. So by dividing by whatever's in front of there, I simplify this to be 1x, or I can write it as just x. And in this case, x is 4. So 5 times what equals 20? Well, 5 times 4 equals 20. Another one-step equation might be something like this. X minus 3 equals 15. So I'm taking x, whatever's happened to x here, x has had 3 subtracted from it. I want to undo that. So the opposite of subtracting 3 is adding 3. So -3 plus 3, remember opposites always equal 0 when they get added together. So x is going to be 18. Let's check it. If I put 18 in here, do I get this side equal to this side on the right? 18 minus 3 is 15. 15 on the left, 15 on the right. Those are the same. So that is our solution. Okay, now if you see also what I had written in this paragraph, it says here, if we want to move an entire term, we add or subtract. So these are separate terms, right? I want to move this whole term, so I'm going to add it. Here, this is the same term. We just want to get rid of the coefficient. We're going to divide. So let's take a look at this one. Now, number 3 here is a two-step equation. Okay, you can kind of see that because there are two things. Here's my x, and it's being multiplied by 2, and 7 has been subtracted from it. So that's two different things that happened. So I'm going to have 2 steps to get that back right to x by itself. So the first thing I'm going to do, it's sort of like the opposite order of operations when I'm doing this because I'm undoing things. It's one way to think about it. Another way to think about it is that the 2 is really stuck to the x right here. I'm going to start with the other term, the one that does not include x. So I have -7. I'm going to add 7 to both sides. So I get 2x. I didn't move that. -7 plus 7 cancels out to 0. And this right side equals 17. Okay, now that's one step. I'm closer to having x by itself, but it's not completely by itself yet. So I am going to have to get rid of this 2. Well, 2 is being multiplied by x, so I can think I want to do the opposite, or also I know I need to divide by whatever the coefficient is to get rid of it. So I'm going to cancel these out. They both equal 1. X equals 17 halves. That does not come out to an integer, okay? Or you could say x equals 8.5, 8.5, 8.5, whatever you want to call it. But leaving it as an improper fraction is perfectly fine. Now, to check this, I want to do something similar to what I did up on top. So I want to take 2 times 17 over 2 minus 7 equals 10. I substitute in what I think my answer is, and you can do this on your calculator, okay? I don't require that you write this out. Remember, let's make this a fraction, and then 2 goes into 2 once, 2 goes into 2 once. So we have 17 minus 7 equals 10. Okay, how did I get 17? Well, 1 times 17 over 1 times 1. 17 minus 7 is 10. Oops. 10 equals 10. Yes, it checks. So if you are doing something like this, where you're substituting in a potential answer, if you are just doing it as its own question, like in number 1 and number 2, saying, does this satisfy the equation? Is this the solution? Then you can either have yes or no as your answer, right? However, if you're checking an answer, you should find out in the check that yes, that is the answer. If you find out in the check that it's not the right answer, that means you made a mistake and you need to go back. So sometimes students get here, check it, it's not correct, and they just leave me a message saying it doesn't check. Well, that means it's not correct, so go back and fix it, okay? So there's a little bit of a subtlety there between those two kinds of questions. Okay, so we're going to go through a bunch of these. I wanted to remind myself how many there are here. So I will, in some cases, pause the video, have you pause the video and go through it on your own, but let's do a couple together to kind of keep moving on it. So again, this is a two-step equation, okay? Now the only difference is it has a fraction in it, but don't let that get you concerned. So I'm just going to write it over here so we have a little bit more space. 2/5 x plus 3 equals 23. So again, something's being multiplied by x, something's being added. I want to take care of this term that does not have x in it first. So I'm going to subtract 3 from both sides. I get 2/5 x, this cancels out, equals 20. Okay, so now I need to work with this fraction. So let's think about what we just said before. If there's a number, a coefficient in front of the x, we want to divide by that number. So I'm just going to write it over here on the right hand side so we can work with it for a minute. So I have 2/5 x equals 20. So I can say I'm dividing both sides by 2/5. Okay, 2/5 divided by 2/5. Anything divided by itself is 1. That works. On your calculator, you can do 20 divided by 2/5, or you can do it by hand. If we did it by hand, let's think about what would happen. We'd have 20 divided by 2/5. I'm going to write 20 as a fraction. Well, when I have fractions being divided, I always keep, change, flip, right? That's how I work with fractions to divide them. I change it into a multiplication problem. So dividing by 2/5 is the same as multiplying by its reciprocal 5/2. So that is generally how we write it when we're dealing with fractions. That way we can do it by hand. So over here, instead of writing that I'm dividing by 2/5, I write this version, which means the same thing. So I'm going to multiply both sides by that reciprocal. So 5 goes into 5 once, 2 goes into 2 once. Those all end up being 1s, or you could think of it as 10 over 10. So I just have x. Here, two things I can do. 20 times 5 is 100, and 100 divided by 2 is 50. Or I could say 2 goes into 2 once, 2 goes into 20 10 times. 10 times 5 is 50. If I check this, I'm going to check it over here now just for space. I have 2/5 times 50 over 1 plus 3 equals 23. So again, if I multiply across the top and the bottom here to check this, I get 100 divided by 5, which is 20. Or I could simplify and I get 10 there. The left side becomes 23, the right side becomes 23. Okay, so sometimes, people aren't sure exactly the best way to study for math. And what you really need to be able to do is recreate what we're doing, not just memorizing, but understanding it. So not only can you do this particular question, but if there was one similar with different numbers, you could do that one because you understand the concept. So a really good way to study is either right now, pause the video, or after you're watching the video, rewrite these problems down on a separate sheet of paper and try them on your own. And if you understand step by step by step what we're doing, that's perfect. If you get stuck, that's okay. Come back to the video, look at your notes, see, okay, what was that step that I was stuck on? And don't just say, oh, well, here's the step, I'm going to move on. But think about why, because if you can't recreate it on your own, then you won't be able to redo it on a test or in a real life situation, right? So you need to be able to make sure you're doing it completely on your own. When either you're watching the video or you're in class, other people, whether it's me or other classmates, tend to kind of fill in the little gaps, right, that each of us isn't sure about. And so you want to really make sure you're taking time to do it completely on your own. Okay, so let's go on to the next one. Now the next one is a little bit more complicated just because there are x's on both sides and constant numbers on both sides. Up until now, we've only had x's on one side. But all we're going to do is we're going to move things around so that all of the x's are on one side and all the numbers on the other, because our goal is to have an answer kind of in this form right here where it's x equals a number. So in this case, sometimes in high school you may have been told to move a certain one. Often we might teach to move the smaller x value just to avoid negatives, but it really honestly doesn't matter mathematically. So in number 5 here, you could start out with the 3x and move that over to the right-hand side. You could start with the 5x and move that to the left-hand side. You could start with a -7 and move that to the right. You could start with a 9 and move that to the left. You can start with any of those 4 and it does not matter, okay? So I'm just going to choose to move the -7 first, and I'm going to do that by adding 7. Now think about like terms. I can move it over here to the right-hand side. I add it to the 9, not to the 5x, right? Because 7 and 5x are not like terms. Now sometimes people like to put a little line down here from the equal sign to remind themselves that whatever they do to one side of that equals, they have to do to the other. So then these are going to cancel out. So we get 3x equals 5x plus 16. And then we subtract 5x from both sides. Right? I want to move this over to the left-hand side so all of the x's are on the left. And then, so since I have a positive 5x, I want to do the opposite, which is to subtract it. So 3 minus 5 is -2x. This equals 16. Just brought that down because these cancel out. Now I'm going to divide because that's being multiplied. I want this to become 1. So this goes in once, this goes in once. So I have x equals, now 16 divided by 2 is 8, but one of these is negative, so I'm going to end up with -8. Now, I may not check all these just because I'm going through in time, but you, whenever you solve a problem that is solving equations, you always want to check the answer because you can, okay? You can know right away whether your answer is true or false, or is correct or incorrect, I should say. So you can put this right in your calculator. Just do 3 times 8 minus 7, 3 times 8 minus 7 equals 5 times, oh my goodness. Let me start over here. It's -8, isn't it? Okay. So let's try this again. Check. It's going to be 3 times -8 minus 7 equals 5 times -8 plus 9. So think about order of operations on each side. 3 times -8 is -24. -24 minus 7 is -31. Over here I get -40 plus 9. I get -31, so yes, it checks. Okay, the two sides are equal. All right, so let's move on to number 6. Now number 6, again, so each of these you can see I'm kind of adding a layer, right? First we started out with a relatively simple two-step equation, then we had one with fractions, then we had one with terms on both sides. Okay, now we have one with some more terms on each side. So I'm again just going to write this over here so I have a little more space. It's a little bit larger. So you notice that on the left side I have 2 terms that have p in them and 1 constant. On the right hand side I have 1 term with p in it and 2 constants. So what I want to do first is I want to combine like terms on each side. Okay, now when I'm moving something, this is like a little bit tricky for people sometimes. When I'm moving something from one side to the other, then I want to do the opposite, right? But when I am doing something on one side, so when working on just one side, do what the operations say. Not the opposite. Okay? So in other words, when I look at this left-hand side, I see 4p minus p. I'm not going to like add p to both sides, anything like that, or add p twice here. I'm just going to do what it says. I'm going to take 4p and I'm going to subtract p. So that becomes 3p. And then I bring down the minus 11 because nothing changed there. And then I look at the right side and I have 2 minus 20. 2 minus 20 is -18, and then I have -18 plus 2p. Okay, so then when we are moving terms across the equal sign, that's when we do the opposite. Okay, so now I say, okay, I'm gonna, move this over. I'm going to add 11 to both sides. But when it's on the same side, number one, we don't do something twice on the same side. We don't say plus p, right? That wouldn't make sense to do it twice on the same side. That would be like giving that left side of the room's plate of cookies, extra cookies twice, and never giving them to the right side. So we just do what it says. But now I'm moving things across, so now I add 11 to both sides because I need to get it from one side to the other. So I have 3p, and again, if it helps you, draw a little line down here to differentiate the two sides. Negative 18 plus 11 is negative 7. And now I want to move the 2p over to here, so I'm going to subtract it. And what does this do? Well, this gets all the p terms on one side. So 3p minus 2p is 1p. I don't have to write the 1, but I can. And the right-hand side is negative 7. Okay, so again, as needed, pause the video, go back, try it again, see what, steps maybe are giving you a little trouble, see what you need to ask about. Okay, so let's move on to number 7. Okay, so 7, 8, and 9, and 10, I think that's where I end up here. 7, 8, 9, and 10 all just get a little more complicated, okay? They all have distributive property in them. We know how to do distributive property. Once you do distributive property, then they're similar to number 6 in that they'll have more than one term on each side that can be combined, okay? So I am going to do number 7 with you, and then I'm going to pause the video and write out 8, 9, and 10, or however far it went, and you can try those on your own and then come back to the video also. But let's look at number 7 first. So we see this, and the first thing we need to do is the distributive property, because we cannot combine terms if they're, stuck in those parentheses. So we're going to do distributive property first. So we get 2x plus 10 minus 7 equals 3x minus 6. Okay, so do you see where I got that, right? I distributed the 2 through, just through the end of the parentheses. It does not distribute to the 7, the minus 7. And then I distribute the 3. Now what I have is very similar to what I had in number 6. So I look at the left-hand side. Are there like terms I can combine? Yes, 10 minus 7, okay? There's no other x term there. If I look at the right-hand side, there isn't anything to combine. So all I have to do is combine those two, and then I can move things from one side to the other. So I have 2x plus 3 equals 3x minus 6. Okay, so take a minute and make sure you know where that came from. Now I have x terms on the left and x terms on the right, and number terms on the left and on the right. So I'm going to move things around. So I'm going to choose to move the 3 over here. Again, you can start with any of these 4 terms in this situation. I generally like to move my constant terms to the right and then move my x's to the left. Okay, so this cancels out. I get 2x equals 3x minus 9. And then I'm going to subtract 3x from both sides. 3x minus 3x is 0. 2x minus 3x is minus 1x, or just minus x. And I get a minus 9 on the other side. Now thinking about this for a minute, this is not just 1x and I'm done. This is minus 1x. I want to know what x is, not what negative x is. So I'm going to divide by negative 1, just like I would divide by any number that's there. So negative 1 divided by negative 1 is 1. Negative 9 divided by negative 1 is 9. Okay, again, you can check this very easily, and if you choose to write it out, that's fine, or you can plug it into your calculator. If you're plugging it into your calculator, just put in one side with the x in there, see what you get for a value, then put the other side in, see what you get for a value. Okay, so I can do order of operations here on the left side. 2 times 14 is 28. 28 minus 7 is 21. Here, 3 times 9 minus 2 is 7. 3 times 7 is 21. Yes, it checks. Okay. So, let's go ahead. I'm going to do numbers 8, 9, and 10 on here. So go ahead and pause the video, and then when you start it up again, I will be going over the answers to those. Okay, so here's number 8. You can maybe pause the video and kind of take a minute to go through it if you need just to look through it and compare it to yours if you need a little bit more time. But in general, we're going to we did the distributive property for both of these, watch the signs for this one, and then on the left side there were two constant numbers that can be combined, 10 and negative 2. Combine those, move things around from one side to the other, we get x equals negative 10. On the next one, here we have just this negative out here in front of these parentheses, and really you can think about that like a negative 1, right? Multiplying something by 1 doesn't change it. Here it's negative, we can multiply it by negative 1. So if you want to put in a negative 1 here, you can think about that, or you can just think of it as the negative, either way. But if I multiply something by negative 1, the number's going to stay the same, or the variable, but the sign is going to flip always, right? Because if it was positive, being multiplied by a negative will make it a negative, and if it was negative, being multiplied by a negative will make it a positive. So I distribute there, and I distribute the 2. So negative 1 times negative 3 is 3. Negative 1 times x is negative x plus 4. We have 2x plus 6 minus 6x plus 7. So then we combine like terms. I kind of, on the left side here, I circled the constant numbers that can be combined. On the right side, I don't know why I did this way, but I circled the x's and then I underlined the numbers. So 2x minus 6x is negative 4x, 6 plus 7 is 13. Negative x equals negative 4x plus 6, because I moved that 7 over by subtracting it. And then I'm going to add the 4x over here to move that over. So all the x's are on the left side. So negative 1 plus 4 is positive 3. 3x equals 6. I divided both sides by 3 to get x equals 2. And finally, I have x plus 2x minus 1. There was one distributive property, 5 times 2x minus 3 minus 2 times x plus 3. So I distributed those. Again, be careful, especially with the signs for this last one where it's a negative. So now I have, again, like terms that I can combine. So I can combine x and plus 2x. So x plus 2 is 3. Over here I can combine 10x minus 2x and I got 8x. And then I can combine negative 15 minus 6 and get negative 21. So I chose to move the 2 over. I get 3x equals 8x minus 19. I chose to move the 8 to the left now because I want all the x's on the left side. I get negative 5x equals negative 19. I divide by negative 5 so that these cancel out. A negative divided by a negative is positive, and my answer is 19/5. And again, it's fine to leave it as an improper fraction, and it's also fine that we get an answer that's not a whole number or an integer, okay? That happens all the time, right? If you go buy a bunch of bananas at the store and you weigh it to see how much it's going to cost, it's very rare that it's going to be, exactly 2 pounds of bananas. It might be 2.7 or 1.8 or something that's equivalent. Like in this case, it's written as a fraction, but it's the same idea. So it's perfectly fine to have an answer that is a fraction. All right, so I had said before I was going to have just one video probably per chapter, but I'm going to stop here on this video just so they're not so long. And then I will continue what we're going to do next, just so you can see what's coming in the notes, is that we have a method to deal with solving equations that have a lot of fractions. And then we're going to talk about dealing with linear equations that have more than one variable. And then we are going to do linear inequalities. Okay, so that's what's coming in the rest of these videos.